Welcome back. In our previous videos, we introduced our main goal, to help you learn how to solve initial and boundary value problems using a new and easy method. We also talked about derivatives, which are important in math. Today, we will learn about antiderivatives and integration, two very important ideas in math that go hand in hand with derivatives. If you want to learn more about antiderivatives and integrals, check out the video linked below. In that video, we explain what an integral is and how it's connected to antiderivatives. In this video, we'll concentrate on polynomial integration, the simplest and most straightforward integral type. This focus is intentional, as it's the only kind you'll need when solving differential equations using our method. Our approach is crafted to be easy, efficient, and robust. Now that we've outlined the main idea of this video, let's get started. Have your notebook and pen ready, and prepare to easily master polynomial integration. Before we explore how to integrate polynomials, it's essential to understand what a polynomial is. A polynomial is a mathematical expression made up of terms that include numbers, known as coefficients, variables, and exponents. In a polynomial, each term consists of three components: a coefficient, a power, and a variable. For instance, in the expression negative 2x to the power of 2, the coefficient is negative 2. The power is 2. And the variable is x. In a polynomial, the term with the highest exponent is called the leading term. The leading coefficient is the number that multiplies this leading term. The degree of the polynomial is the exponent of the leading term. The constant term is the term without a variable. A term is a part of a polynomial, separated by a plus sign. For example, in the expression 3x to the power of 5 minus 2x to the power of 2 plus 7, the terms are 3x to the power of 5, negative 2x to the power of 2, and 7. In polynomials, exponents should be whole numbers. Additionally, variables should not appear in the denominator. Inside a radical, or have negative exponents. If you're enjoying this video so far, don't forget to like it, share it with others, and subscribe to the channel for more videos like this. If you have any questions or thoughts, drop them in the comments below. We'd love to hear from you. Now that we know about polynomials, let's learn how to integrate them. Integration is simply a process we use to find the antiderivative of a function. In this lesson, we'll go through the steps to integrate polynomials, and it's easier than it sounds. Let's get started. To integrate polynomials, simply increase the exponent of each term by 1. And then divide that term by the new exponent. To integrate a term like a times x raised to the power of n, you can follow these steps. First, add 1 to the exponent n. Then, divide the coefficient a by this new exponent. Finally, you will have the result as a divided by n plus 1 multiplied by x raised to the power of n plus 1. This process helps you find the integral of a term of this form. To integrate 3 times x squared, here's what you need to do. First, increase the exponent by 1. So, the exponent of x goes from 2 to 3. Next, divide the coefficient, which is 3, by the new exponent, which is now 3. When you do this, 3 times x squared becomes 1 times x cubed, or simply x cubed. Let's now find the integral of 3/5 times x. First, we increase the exponent of x from 1 to 2. Next, we divide the number in front of x, which is 3/5, by the new exponent, 2. So, we divide 3/5 by 2, and then multiply the result by x squared. When we simplify this, we get 3/10 times x squared. Let's not forget about constants. When you're dealing with a constant, like the number 5, the rule for integration is straightforward. You simply multiply the constant by x, and the result will be 5 times x. Let's break it down step by step. We're trying to integrate the expression 3 times x squared minus 3 divided by 5 times x plus 5. Here's how we do it. First, for 3 times x squared, the result becomes x cubed. For 3 divided by 5 times x, we get 3/10 times x squared. And for the constant 5, the result is simply 5 times x. So, putting it all together, the integral of 3x squared minus 3 divided by 5 times x plus 5 is equal to x cubed minus 3/10 times x squared plus 5x. When you finish the integration, there's one last important thing to keep in mind. We always add a constant, often labeled as c. This constant is necessary because there are multiple functions that, when differentiated, can lead to the same result. And that's all there is to it. Integrating polynomials is simple once you know the basic rule. Increase the exponent by 1, divide by the new exponent, and don't forget to add the constant of integration. Try practicing with a few examples, and soon you'll be solving them like a pro. When dealing with more complex functions in integration, we often rely on special techniques. These methods can help simplify the process and simplify the calculations. Some of the key techniques include integration by parts, integration by substitution, integration by partial fractions, integration using trigonometric identities, and other advanced methods. These techniques are essential for solving integrals that don't easily fit the basic integration methods. With our method for solving differential equations, you won't need to worry about complicated techniques anymore. All you need is to know how to integrate polynomials. It's that simple, and you're going to love how easy it is. Isn't it amazing? I'm sure you're already falling in love with our method because it's straightforward and requires no fancy techniques. You now have everything you need to start tackling differential equation, often called DE. In the upcoming videos, we'll introduce you to an incredibly powerful yet surprisingly simple method for solving differential equations. This method is so unique that even many mathematicians aren't familiar with it. So, stick around and get ready to learn one of the most amazing techniques in mathematics. No complicated steps required.